You know, for pretty much our entire digital lives, we've been operating on a foundation that's, well, fundamentally broken. Today, we're going to look at the architecture of a huge, and I mean irreversible shift in who actually controls our digital identity, a shift away from giant corporations and back to us. So let's dive in. It's a tough pill to swallow, but it's the honest-to-God truth of the internet right now. All your most important info, your identity, your health history, your finances, it doesn't actually live with you. It's sprinkled across hundreds of different company databases. Sure, they give you a password to access it, but let's be real, you don't actually control it. And when you pile all that valuable data into one place, you basically painted a giant glowing bullseye on it for hackers. This old way of doing things, it all but guarantees those massive, catastrophic data breaches we keep hearing about in the news, seemingly every other week. Okay, but what if we could just flip that whole model on its head? What if we could build an entirely new foundation for digital trust, right from scratch? Well, that is the incredible promise of personal data sovereignty.
So here's the core idea, and it is a game changer. Instead of some company holding your data, you hold it, right there on your phone in a super secure encrypted vault. And get this, when someone needs to check something, like your age, you don't hand over your whole driver's license with your address and everything on it. No, you just share a simple mathematical proof that says, yes, this person is over 18. That's it, nothing more.
Now, as amazing as that idea sounds, the first drafts, well, they had some pretty big issues. Before this could actually become a reality, the architects had to hunt down and solve 4 really critical design flaws. And that brings us to the first massive problem. See, some of the early models wanted to route everything through a central hub to keep track of it all, but that creates a huge privacy problem, doesn't it?
The real danger here isn't even the data itself, it's the metadata. The middleman might not see what you're sharing, but they see when and where you're sharing it. And that alone can build a pretty detailed profile of your life. The modern solution is, frankly, brilliant. It's called a blind orchestrator. Just think of it like a mail carrier for the internet. They know a package has to go from your address to a destination, but they have no idea what's inside the box. They can't open it, they can't scan it, they just deliver it. Your privacy stays completely intact.
Flaw number 2 was a head-on collision between technology and the law. A lot of early designers wanted to use blockchains because they're permanent and can't be changed. But then you have laws like GDPR, which guarantee your right to be forgotten. So, how do you delete something from a database that's designed to never, ever be deleted? And the fix for this is just so elegant. It's called functional erasure. The trick is simple. You never put your actual personal data on the blockchain to begin with. The only thing that lives on-chain is your public ID. If you decide you want to be forgotten, you just delete the data from your own device and deactivate your ID on the chain. That cryptographic link is severed. It's gone. The old data is useless, and you've satisfied the law without trying to do the impossible. It's perfect.
Okay, flaw number 3. Let's say your digital driver's license gets revoked. How does a bar or a shop know it's not valid anymore? The old way was for their system to phone home to the issuer's server every single time. And just like that, you've got another massive privacy leak, with the issuer being able to track your every move.
The new solution cuts that cord completely. It uses something called a bitstring status list. Sounds fancy, but the idea is simple. The business just downloads a tiny, compressed file, like a digital do not admit list, of all the revoked IDs. When you show your credential, they check it against that local list on their own device. No callback to the issuer, no metadata leak, no tracking. It's all done privately, offline, and it's lightning fast.
And the last big hurdle was just raw horsepower. For a long time, people assumed the intense math needed to create things like zero-knowledge proofs was way too much for a normal smartphone. The only workaround was to send your private data to a powerful cloud server to do the number crunching for you, which, completely defeats the whole point of privacy.
But it turns out that's not a problem anymore. Not even close. The answer was literally sitting in our pockets the whole time. It's the GPU, the powerful graphics chip that runs all your games. Modern toolkits can now tap into that power and generate even the most complicated proofs in milliseconds. Not minutes, milliseconds. And it means all of your sensitive data stays right where it belongs, on your device. So, with those 4 major flaws squashed, we can finally look at what the real, state-of-the-art architecture looks like for 2026. Let's see how all these pieces come together to build a true system of trust. One of the biggest design choices is what kind of zero-knowledge proof you use. And as you can see, it's all about trade-offs. On one hand, you have ZK Starks. They're resistant to quantum computers, which is awesome for the future.
But look at that payload size, up to 200 kilobytes. That's just way too big for a spotty mobile connection. On the other hand, you have ZK Snarks. At just 288 bytes, they are absolutely tiny. For the speed and efficiency we need on the phones we have today, ZK Snarks are the clear winner.
So let's walk through what this actually feels like in the real world. A website requests a proof from you. That blind orchestrator we talked about securely routes the request to your phone's wallet. You get a notification, you give a quick glance for Face ID or a touch for fingerprint, and that unlocks the keys in your phone's secure hardware. Then, the magic happens. Your phone's GPU generates that tiny ZK Snark proof in a flash. The website validates it, and you're in. The whole thing is seamless, totally private, and it's over in less than a second.
Okay, now this is really important to understand. This isn't just some cool tech theory from a lab. This shift is being forced into existence by some incredibly powerful legal and economic forces. This is happening now because it has to.
Let's just start with the money. $7.4 billion. That's the projected size of the decentralized identity market in 2026. When you have an economic engine that massive, it fuels innovation and adoption at a blistering pace.
But you know what's even more powerful than the market? The law. And governments are no longer asking, they're mandating. Just look at this timeline. By the end of 2026, every single country in the EU must offer its citizens a digital identity wallet. And starting in 2027, the very largest online platforms will be legally required to accept them. This isn't optional anymore.
So what's the big takeaway here? For businesses, it's huge. This idea of reusable KYC, know your customer, slashes their identity verification costs by up to 60%. For you, it means your personal data is no longer sitting in some vulnerable server just waiting to be stolen. And for everyone, it marks a fundamental shift back to individual ownership and control, all backed by the force of law. So when you put it all together, the technology is built, the laws are in place, and the money is pouring in. For the first time, your digital identity is truly becoming your property, a digital asset that you own and you control. The only question left is, what are you going to do with it?